So the problem I wanted to do today is the problem of a box on an inclined plane. It's frictionless. So the way we solve this problem is the way we solve every single other problem. So we're going to have a free body diagram that we start with. So we've got the weight of the mass due to the Earth. We have the normal of the mass due to the surface. Here's where things get different. Step 2 says forces at angles, we need to split it up into those angles. Now here's the new rule, and this only works for inclined planes. We're not going to split the normal force. We're going to in fact split the weight, and here's the directions it goes. So weight has two components, one that goes along the normal and one that goes perpendicular to the normal, sliding down the inclined plane. Okay. So one component of the weight goes like this, and the other goes perpendicular to the normal. Now, this component of the weight that slides down the inclined plane, it actually ends up being, let's actually go ahead and get it. So I'll actually give you the formula. It's going to be WME, and we times it by, I'm just going to give you this rule, and we're just going to use it, times the sine of the angle theta. And the part that goes perpendicular exactly along the line of the normal force, that's going to be WME times the cosine of the angle. And that's how we're going to set up our equations. So what happens is we actually have two equations. One along the normal weight direction, so we'll call this direction y. And then one for the sliding down the inclined plane, and we'll call that x. So when we set up our equations, they look like this. In the x direction, I'll have WME times the sine of theta is going to equal m times a. In the y direction, I'm going to have WME, I'm going to have the normal force minus WME times the cosine of theta, and those forces cancel. So in other words, I'm just reading my forces off this picture. What I haven't proved is the stuff in red. We're just going to use that in class. If you want a mnemonic, sine makes me slide, I like that noise, and cosine cancels the contact force. So cosine cancels. And we use that rule to set up the equations. Now what I'm going to have you do in the Google Docs next to the video is you're going to actually determine for me the value of the normal force and the normal of the the value of the acceleration of this block. And those will be the things that we do. And then we're going to start class with this problem fresh, so you guys get a fresh view of it in the morning.